All right, guys, lesson 1.1, absolute value functions. That's kind of the topic for the day. This early in the year, if you're watching this video, it's probably either because you made some class changes and you're playing catch up, or maybe you're just trying to grasp some things that you didn't understand in class very well. So on these videos, we're going to talk about the examples. We're going to go through the textbook because, like we mentioned in class, one of the goals this year is to try to help you get better at using a textbook. So 1.1 absolute value functions. In this book at the beginning, there's always kind of a little activity. Sometimes we'll do those on the videos. We are definitely not at home. You don't need to do those. We're just going right down here to the lesson. All right. So before we start talking about absolute value functions, over here on the left-hand side, you see some vocabulary terms. The first three are going to be new terms. So I don't expect you to know those right now, but it says that it expects you to know what domain and range is. So really quick before we get into the new stuff today, I want you to remember domain. That was a big part of what you learned about last year. Domain is all of the x values that can be used in a function. Okay, it's all the x values that can be used in a function. If you look at the graph, that is the left to right. That's your domain. Your domain goes left to right. The range, if you haven't guessed already, or if you don't remember, is all of the y values that come out of a function. That come out of a function. You don't put the range into a function. The range is what comes out of the function. And this is the up and down of a function, all right? Something that I think it's important for you to remember going into not just today's lesson, but we are going to be using this one, these two terms a lot. So moving on, absolute value function. Now, I don't know how much experience you have with this function. It's not part of the core in any of your previous classes. So just to explain a little bit about this function. So an absolute value function is a function. You can graph it. And it has an absolute value expression, which usually looks like absolute value of x. That's what these little lines right here are called. Those are the absolute value lines. So if I had like y equals this symbol x minus 3, I would say y equals the absolute value of x minus 3. So anything with those bars in it is an absolute value function. And it usually looks like this right here. It usually looks like this blue V right here that's graphed for you. The point down here at the bottom where it changes direction, that's called the vertex. That's going to be an important point today. We're going to focus on that a lot. Now, the function that you see right now, this is what's called a parent function, because the function that you're looking at is f of x equals the absolute value of x. There's no other numbers. There's nothing else going on. It's just the parent normal base function f of x equals absolute value of x. And a couple of key notes about this. It starts at 0, 0. And the slope of my lines, as I go up to the right, I go up 1 over 1, up 1 over 1, up 1 over 1. So my slope is 1. As I go to the left, my slope technically is negative 1, right? Because it's going down 1 over 1, down 1 over 1 as I go left to right. Those are two of the main features I want you to know. It starts at 0, 0. It has a slope of 1, all right? Two other important things is the domain and the range. If I look at my arrows, they go to the right forever. They also, this implies, this arrow over here, that it's going to go to the left forever. So that's why it says that the domain of f of x equals absolute value of x is all numbers. Going to the left and the right, I'm going to hit every single number going left and right. But my range, if you notice, my function comes down, it hits 0, and then it goes back up. and my arrows at the end are both pointed up. That means my function is never going to go below 0. So my range is all the numbers above 0, and it's written right here. The range is y is greater than or equal to 0. All right, so there's your introduction to your absolute value function, your base absolute value function. So all of the other, everything else with an absolute value in it is this same function but manipulated. It might be moved up or down or flipped over or squished or stretched. It's going to be this same function, but as you introduce other numbers into the function, it makes it do different things. So that's what we're going to kind of explore today, is what happens when I do different things to my function. All right, so first thing that we're going to explore in our textbook is example number 1. And it says, example A says that g of x equals the absolute value of x plus 3. And it wants me to graph this and see what happens. So if you really have never seen the absolute value function before, then this whole thing is going to be brand new for you, because what we need to do is we're going to start by making a table. And you're not going to have to do this on every single problem. On some of them you are. Once you learn the shortcuts and the tricks, you're going to be able to skip that step. But for now, to graph this, I'm going to make a table because I don't know the tips and the tricks yet. All right. So what I do is I pick some x values. So I've got -2, -1, 0, 1, and 2. And I know on your paper you have numbers written in right here, but I haven't written those in yet. So what I'm going to do, I'm going to take this -2 and I'm going to plug it in right there where the x is. So that becomes the absolute value of -2 plus 3. Now what these two bars right here mean is whatever is on the inside, once I get it down to one number, like -2, those bars turn it into a +2 plus 3. That's what those bars do. They take the final number inside, whatever everything combines into, and it turns it into a positive value. So when I plug in a -2, it turns into a +2, and I add 3, so I get 5. So I'm going to graph that right here, -2, and I'm going to go up 1, 2, 3, 4, 5. I'm just graphing it over here on the left. Again, I think you might already have this graph. I want to show you the process of graphing this, okay? -1, if I plug in a -1 right here, if I make that a -1, it turns into a +1, and then I add 3, so I get 4. So at -1, my function's at 4. If I plug in 0, the absolute value, it's still 0. Plus 3 is 3. So I go, I don't go left and right at all, but I go up 3. If I plug in a 1, the absolute value of 1 is 1, plus 3 is 4. So I go over 1 and up 4. Well, that's interesting. I already got a 4. I got a 4 right here, and I'm getting another 4. That happens with absolute value graphs, right? If I plug in a +2 into my function, I get 2 plus 3, which is 5. So I graph that. Over 2, up 5 is right here. So now I connect my points. And if you notice, it looks a lot like the old graph. The only difference is what? It's shifted up. It's not moved left and right, it's moved up. And if I count, it's moved up 1, 2, 3, which is not a coincidence because we added 3 on the outside of our function. So right now I can kind of make a guess. I can guess that if I don't want to use that. If I add 3 on the outside, it moves up 3. That's what happened when I graphed this, okay? So let's try another one. Let's see what happens when we do something to the inside of my absolute value. So if you notice on example B, m of x equals the absolute value of x minus 2. So the minus 2 is on the inside. So let's go ahead and plug in some numbers. I'm going to plug 0 in. 0 minus 2 that's negative 2, but my bars take that negative 2 and turn it into a positive 2. So on my second graph, I'm going to put 0, 2. All right, if I plug in a 1, 1 minus 2 is negative 1, but my bars turn that negative 1 into a positive 1. So I've got the point 1, 1. Let's plug in the 2. Plug in 2 minus 2, that's 0. Absolute value of 0 is 0. So as I go over 2, I don't go up and down at all. If I plug in a 3, 3 minus 2 is 1. It's already positive, so it stays a positive. Over 3, up 1. And by now, hopefully you know, oh, if I plug in a 4, 4 minus 2 is 2. Absolute value of 2 is 2. So I go over 1, up 2. So if I look at this graph, ooh, that was not a straight line. Not even close. Oh my sakes, Mr. Reed. There we go, that's a little bit better. If I look at this graph, it looks the same as well, but this time, instead of going up and down, it moved me to the side. So a negative 2 on the inside, what did that do to me? That moves me 2 to the right. That's interesting. It went the opposite. I would guess that it was going to go 2 to the left, but it moved it 2 to the right, okay? Let's keep going. Let's try a couple of these that aren't already. I know those are on your paper. They're worked out. I like you to see them actually get worked out. But if you're looking at your book, you can just follow their work. Hopefully, you'll start to learn how to follow their work, right? So number 1, these monitoring your progress. The idea behind these problems is to practice what you're learning, okay? It's your opportunity to try and do this problem. So what I would like you to do, it wants you to graph the functions right down here, number 1 and number 2. And then it wants you to compare the graph to our normal, original, regular parent function, right? So, oh, you know what? One thing that it does want us to do is describe the domain and range, and we did not do that on these other problems. So let's look at what happened really quick before we do those. On example A, that moved up 3. Now on this one, my arrows are still going left and right forever. So my domain is still all real numbers. That's what that symbol means. But I stop, when I'm going down, instead of stopping at 0, now I stop at 3. I don't go below 3. So my range is going to be, my y values are always greater than or equal to 3. I never go below 3, okay? Now let's look at the second one. I moved to the right, but did that change my arrows going left and right? Just because I moved to the right, I'm still going left forever and I'm still going right forever. So my domain on the second one is still all real numbers, all right? My range, if I look at my up and down, I go down to 0 and then I go back up. So my range is going to be, my y values are always greater than or equal to 0. They don't ever go below 0, okay? All right, so now that we mentioned domain and range, I talked about how important that was and then I forgot all about it. Number 1 and 2, I want you to pause the video and I want you to try to do these problems on your own without my help. So go ahead, hit pause, try numbers 1 and number 2 in your notebook. When you are done with them, I want you to restart the video and I'll actually walk you through those 2 problems. Okay, guys, so number 1, it wants me to take the absolute value of x. Oh my, that's gonna, okay, there we go. The absolute value, can I move this over? Hey, cooperate. There we go. Absolute value of x. So h of x equals the absolute value of x minus 1. All right, so it wants me to graph this function. Now, the second function, we're going to use what we learned. This function, I'm going to practice with my table. I'm going to pick a couple of values, okay? And so these will be my x's on top and my y's on the bottom. So let's pick, what do we want to start with? 0. If I plug in a 0, I get a -1. Cool. If I plug in a 1, what do I get? The absolute value of 1 is 1. If I minus 1 from that, I get 0. Okay. What else would make sense to try? How about -1? If I plug in a -1, I get it turns into a +1. And then when I subtract 1, again, I get 0. Maybe I should be graphing these as I go, huh? I go over 0, I go down -1. So there's 1 point. I go over 1, and I go up 0. I go over 1 the other direction, I go up 0. Well, let's see what happens at 2. If I plug in a 2, the absolute value of 2 is 2, minus 1 is 1. So if I go over 2, I go up 1. And if I plug in a -2, it gets turned into a +2. And then I minus 1, and I also get 1. So at -2, I also go up 1. So when I graph this, what happened? It looks like my normal graph, except for it went down 1. Which we expect, right? Because there's a -1 on the outside. So my graph went down 1 because there was a -1 on the outside. My domain, we're not going to forget this time. My domain, I still go left and right forever, and I'm going to give you a hint, guys. With absolute value functions, they always go left and right forever. So my domain is almost always going to be all real numbers, unless for some reason it's turned sideways, which we don't do in this class. My range, my up and down. So I go down, I pass 0, I go down to -1, and then I go back up. So my y values never go below -1. So I write y is always greater than or equal to -1, okay? So hopefully you got the same things. When you did this problem, hopefully you got the same answers as I did. All right, the second one, n of x equals absolute value of x plus 4. All right, so let's give this one a try. N of x, nope, quit moving, guy. Stop it. N of x equals the absolute value of x plus 4. Now let's go ahead and use our shortcut on this one because we learned some things. Earlier up here, I learned that if there was a -2 on the inside, then my function shifted to the right 2. So what do you think is going to happen if there's a +4 on the inside? Instead of shifting to the right 4, it does the opposite. It's actually going to shift 1, 2, 3, 4 to the left. Other than that, it's going to be the same thing. It's going to go up 1 over 1, up 1 over 1, and it's going to do the same thing going the other direction. All right, so my domain. Let's talk about my domain. I still go left and right forever. Oh my gosh, it's all real numbers. Shocker. My range, as I follow my graph, it goes down to 0 and then back up. So my range, whoops, I already wrote range. My range is going to be y is always greater than or equal to 0. It never goes below 0. So hopefully that's what you got, whether you use the table or the shortcut. Hopefully you got the same idea, right? Okay, let's talk about doing other things to the graph because it doesn't just move left and right and up and down. That would be nice if it did, but the world doesn't work that way. It does other things. So example 2 talks about what happens when there is a number in front of the absolute value. So it's not being added or subtracted. It's just right in front of it being multiplied. That would be the same as saying like a with a parenthesis x. The rules apply. That a is being multiplied by the absolute value of x. So it wants us to graph these two functions. We're going to go ahead and do so. And I know it's already done in your book. I don't care. I want you to see the process because this is what you should be doing in your head, right? So my first function is 2 times the absolute value of x. So I'm going to plug some numbers in. I'm going to plug in a -2, and that turns into a +2 and gets multiplied by 2 and becomes 4. Now I'm going to plug in a -1. That turns into a +1, gets multiplied by 2, and becomes 2. I plug in a 0. Absolute value of 0 is 0. 0 times 2 is still 0. That hasn't changed. If I plug in a 1, absolute value of 1 is 1 times 2 is 2. If I plug in a 2, the absolute value of 2 is 2 times 2 is 4. All right, so let's go ahead and plot these points. So I've got -2, but I'm going to go up 1, 2, 3, 4. So that's up here. If I go -1, I'm going to go up 2. I'm at 0, 0. And then as I go over 1 to the right, I'm going to go up 1. As I go over 2, I'm going to go up 4. So when I plot this, what has changed? It's still right in the middle. It hasn't moved. It's not left. It's not right. It's still right in the middle. But if I look at my slope, my original function, maybe I should plot that on here. My original function goes up 1, over 1, up 1, over 1, up 1, over 1. My original function would look like this on the right. But this function goes up 2 over 1, up 2 over 1. So that 2 out in front, that changed my slope. It made my function more steep. It made it steeper. Is that a word? Steeper? I think that's a word. The 2 made my function steeper. And what the way that we say that is that the 2 stretched my function, okay? The 2 stretched my function. It made it taller and skinnier. I call this the marshmallow rule, because if you were to take a marshmallow and stretch it, it's the same marshmallow, but it gets taller and skinnier, right? As you stretch the marshmallow, it gets skinnier. So that's why we call this a stretch. Well, that's probably not why it's probably not marshmallows that made us call it that, but I like the comparison. So a number out in front looks like it changes how wide my function is. So that 2 stretched it and made it taller. Cool. Well, let's look at the next one. It's all the way up here, -1/2 x. So I'm going to write that down here, -1/2 absolute value x. All right, let's plug in some numbers. If I plug in -2, it gets turned into a +2. But then I have to multiply it by a -1/2. So if I have a -1/2 multiplied by a +2, that's not just 1, that's a -1. Right? Because the negative's on the outside, not the inside. So that becomes -1. So let's plug in -1. If I plug in -1, that turns into a +1, but then that has to get multiplied by -1/2. Well, 1/2 of 1 is a half, and a negative is a negative. So that becomes -1/2. Ooh, maybe let's start drawing this. So if I'm to the left 2, I'm going up 1. And if I'm to the left 1, I'm only going up a half. Now, if I plug in 0, I love plugging in 0 because 0 turns into 0, which multiplies and stays 0. So I've got this point 0, 0. Now, if I plug in a 1, absolute value of 1 is 1. Multiplied by a -1/2 becomes -1/2. Ooh, guess what, guys? I'm plotting this wrong. None of you told me. Why is no one here? I'm going down. I'm going -2, -1. -1, -1/2. Here I am doing things all wrong, and none of you are telling me. 1 down a half. So I go over to the right, and I go down a half. And then if I go over 2, can you guess what's going to happen? Yeah, I'm going to go down 1. They picked good numbers. So when I graph this, look at what's happened. Okay. Well, first of all, it completely changed. It flipped upside down. Second of all, it looks... I mean, my other graph did what? It went over 1. Like if I were to flip over my normal graph, it would go over 1, down 1, over 1, down 1. So it would look like this. Over 1, down 1, over 1, down 1. So This time, my graph isn't taller and skinnier. My graph has been like smushed. It's been like squished. So imagine you take a marshmallow and you squish it, right? If I were to squish the marshmallow, it's going to squeeze out the sides of my finger and it's going to get fatter. It's going to get wider. We call that a shrink. So the negative 1/2, what did that do? It flipped it over and it shrunk it. It squished it. It made it fatter. So what made what happen? What do you think did what? Because two things changed. In the first problem, I had the number 2, and that made it tall and skinny. In the second problem, I had a negative, but I also had a fraction. So I'll give you a hint. The negative is what flips it over. Well, duh. This negative in front is what made this a -1 and a -1/2 and a negative and a negative. So the negative in front is what caused it to flip over. The 1/2, because that's a number smaller than 1, that's what shrunk it, okay? The negative flipped it over, the 1/2 took it and made it shrink. Notice on this one, my domain, it still goes to the left and right forever. Cool. So my domain is still all real numbers. But what about my range? Instead of going down to 0, now I'm going up to 0 and then I'm going down. So my range, y, is always less than or equal to 0. Instead of being greater than or equal to 0, it's always going to be less. Cool. Good information. So the point of all of this, and there's notes all over in your textbook. If you read right here, a vertical stretch of the graph is narrower than the normal function. Cool. A shrink is wider than the normal function. Cool, that's good information. As I'm reading through my textbook, that tells me some interesting stuff. It also tells me up here, hey, a negative in front reflects my graph over x. Cool. We don't worry about a negative on the inside. We don't do those this year. All of these things are in your notes, right? They're there to be found. But let's try a couple of these. And we're going to, now that we're getting better at this, we're going to try to do this without a table, okay? So we're going to try to do number 3 down here. Actually, you are going to try to do number 3. Pause the video, try to do these 2 examples, see if you can draw the picture of the graph. You don't have to do a table, but see if you can draw a picture of the graph and make it look correct. All right, welcome back. Hopefully, this is what your picture looked like, okay? So my function, I know that it's going to be upside down. That's what that negative tells me. So it's not going to go up. My function's going to go down. Now I need to consider what the 3 means, okay? It's not a fraction, so my function is not going to get fat and wide. My function is going to get tall and skinny. That 3, remember, that 3 is my kind of like my slope. So if I'm starting at 0, 0, then that 3 means I'm going to go down 1, 2, 3 before I go over 1. And then I'm going to go down 1, 2, 3 again before I go over another 1. So that 3 right there is kind of a hint at what my slope is going to be. Oh man, I missed my dot. I'll just make it bigger. There we go. Cool math trick. Going the other direction, I'm going to go down 1, 2, 3, and then I'm going to go to the left 1. And then I'm going to go down 1, 2, 3, and I'm going to go to the right or to the left another 1. So hopefully your graph looks something like that. It's upside down, and instead of going over 1 and up 1, it's going to go up by 3s this time. Okay? All right. Oh, domain and range. I keep forgetting. The domain, left and right. Oh my gosh, all real numbers. Amazing. My range this time, I go up to 0 and then I go back down. So my y values are always less than or equal to 0. All right, let's look at the other example. God, this video is like running 800 hours long. v of x equals 1/4 x. All right. So v of x equals 1/4 x. All right, so my function is not upside down because it's not a negative. But that 1/4 is going to make me short and fat instead of tall and skinny. So how short and fat? Well, remember, that's kind of like my slope. So that means, if you remember your slope, rise over run, that 1/4 means I'm still starting at 0, 0, but I'm going to go up 1, and I'm going to go over 1, 2, 3, 4. Then I'm going to go up 1, and I'm going to go over 1, 2, 3, 4. So this one is really short and wide. And the same thing to the left. I'm going to go up 1 and over 1, 2, 3, 4. And then I'm going to go over 1, 2, 3, 4, but I'm only going to go up 1. So it's going to be a lot wider than the other functions. Now my domain is still the same. It's still all real numbers. But my range this time, my y values are always greater than or equal to 0. Okay. Moving on, because this is a whole, you know what? Let's stop for just a minute. And here's what I want you to do. I want you to open your notebook and I want you to write this down right here. We're going to add some stuff to our notes, okay? Write y equals a absolute value, x minus h, absolute value plus k. All right, so here's what I want you to write. The k value, what did the k value do? Do you remember? It moves up or down. That's what my k value did. It moved me up or it moved me down. My h value, what did that do? It moves left or right, but it did it in the opposite direction than you would think, right? If it was a minus, it moved it to the right. If it was a positive, it moved it to the left, okay? And the a, if it's negative, it flipped, right? If it was bigger than 1, it stretched. If it was smaller than 1, it shrunk. So we'll say that a is equal to the slope, right? If it was a negative, it flipped it over. If it was a number bigger than 1, it stretched it. If it was a number smaller than 1, it squished it like the marshmallow. Okay, so now using our notes, let's combine these transformations, all right? It says let g of x, I'm just reading right here, let g of x equal -2 multiplied by the absolute value of x minus 1 and then add 3. Well, I know some things. This -2 is going to do what? It's going to flip it, and my slope is going to be 2. It's going to stretch it. This -1 on the inside, what's that going to do? That's going to move, the word that we use is shift. That's going to shift it 1 to the right. Cool. Now how about the +3? So the +3 on the outside is going to shift it up 3. Okay, the -2 is going to flip it over and make my slope 2. It's going to stretch. Maybe I should write stretch. The -1 is going to shift me to the right 1, and the +3 is going to shift me up 3. All right. I'm not doing the table. I'm sorry. I know the shortcuts. I don't want to go through the time and make a table because guess what? I learned some things. So over here on my graph on the left, I want to do that. I'm going to start at 0, 0 because that's where I always start. And I'm going to shift to the right 1. So that takes me to here. But then I'm going to go up 3. 1, 2, 3. So my new vertex is right here. This is where I'm going to start. Now I need to flip it upside down. Cool. It's going to be upside down. I can't flip it yet because I haven't drawn it, right? But my slope is going to be 2. So that means from this point, I'm going to go down 1, 2, and over 1. Then I'm going to go down 1, 2, and over 1. So here's my right side. Now my left side, I'm going to go down 2 and over 1, and then down 2 and over 1. So here's my left side. So it's skinnier, it's upside down, it's moved to the right, and it's moved up. Awesome. I like that graph. My domain, oh my gosh, not equals. I don't want to put equals. My domain is all real numbers. And my range, my y values, I go up to 3, and then I go back down. So my y values are going to be less than or equal to 3. Okay, I know in your book you have this big complicated picture. It's just showing you all the different changes on one graph, and that gets a little bit confusing. So that's what it looks like when you're done. So on this graph, the one that's actually your finished product is this red one right here. Everything else is just everything that you did to it. Let's do, we don't need to do method 2 because we already did method 2. All right, number 7. This problem we need to change. It says let g of x equal negative 1/2 x squared plus 2 plus 1. I'm going to change that. Let's say g of x is equal to, let's do negative 1/3 on the outside, x plus 4, and then let's do let's do plus 2. Okay, what I want you to do is I want you to pause the video, and I want you in your notebook, I want you to write this function, and I want you to graph it. Okay, write that function and graph it. Okay, welcome back. Let's graph this function, huh? So if I have my coordinate plane here, now let's look at what happens. This negative flips me over, right? So I'm going to get a flip. It's going to flip. This 1/3 is my slope. My slope is going to be 1/3. That's going to make it short and fat, right? This plus 4 is going to make me move to the left 4. And what am I missing? This plus 2 on the outside is going to make me go up 2. So let's do all of that. First thing I'm going to do, I'm going to go to the left 1, 2, 3, 4. And then I'm going to go up 1, 2. All right, so here's where I start. There's my vertex. I go left 4, up 2. Now I need to flip it. Cool, it's flipped. Now my slope is 1/3. So think about what that means. That means I'm going to go down 1 and over 1, 2, 3. So my point is going to be right here. And then I'm going to go down 1 and I'm going to go over 1, 2, 3. So my point is going to be right here. I need to make some more points over here. Okay, now going the other direction. 1/3 means I go down 1 and over 1, 2, 3. So I've got a point right. Oh no, it went away. Right there. And then I go down 1 and over 1, 2, 3 again. So my function should look something like this. Yours is probably a lot better looking than mine. My domain is all real numbers, right? My range, look at my y values. I go up to 2, right? That's 2. And then I go back down. So my y values are always less than or equal to the number 2 because this flipped upside down. All right, time for you to practice. Oh my gosh, that was like forever. These are your homework problems. They're on the calendar, on Canvas, but I want you to do 5 through 25, the odds, 33 through 37, the odds, 41, 42, 50. Now these ones with the stars. The star doesn't mean if you want to do it. The star means these are hard problems. They might be difficult. You might not be able to figure them out, but I need you to work on them. Okay, the star does not mean it's optional. The star means It's going to be challenging, but I want you to try. All right. Good luck. We'll see you in class.